Hello friends, welcome to my YouTube channel, and in this video I'm going to talk about this web app which I have created for civil engineers. Okay, so if you are from civil engineering field or for mechanical engineers also, see what you can do here. There are three apps within this single website. This website is not live as of today, but after a few maybe weeks or months, surely I will take it live. Okay. So what I have created here, let me show you. So this is my home page, and I have created three apps. Okay, so one is for drawing shear force and bending diagram for statically determinate beams. Okay, and it can take different kinds of loads and different supports, even internal hinges. And this is for drawing Mohr circle. Mohr circle, this concept is related to stresses. Okay, and this is a app for vertical drawing vertical curves. So we know there are two kinds of curve, that what one is valley and summit curve. So this is related to highway engineering or surveying. Okay, so these are three apps. Okay, so first of all, whenever you want to use these apps, you have to create an account. Okay, so just put in your name, email, and choose some password and submit, and you will get your uh, user account. And after creating user account, simply go to this page, sign in. You will automatically get signed in when you sign up. So when you sign up, you will be taken to this home page. When you log in like this, you will see that initially there were only this home Mohr circle, and this was not visible, and even these only one of these apps would be active. I mean, it would be available for you to use if you are not logged in, but once you log in, all of these three apps, they will be available for your use. So let us go to one of these uh, apps. So let us suppose you want to draw Mohr circle. Okay, so click on this Mohr circle, and you will be taken to this page. So here you have to put your inputs. Okay, so you know sign conventions. Tensile stress is positive, anti clockwise is, that is anti-clockwise is the direction of the plane. So if you want to find out the stresses on any particular plane, then you have to give the degree of that plane. Okay, so how much rotation from the x-axis. So if it is anti-clockwise, then that is positive. So that is the standard sign convention. So let us suppose our sigma x is 100 MPa, and you can choose any unit here. Suppose I want to use kPa, simply type kPa. Okay, and here sigma y, let us suppose this is 10, and let us suppose your shear stress is also 10, and plane on which you want to find stress is, let us suppose it is at 30° anti-clockwise. And you have option of choosing Mohr circle method or transformation equations, so you can use both or you can use both of these methods. Okay, so if you want solution using the transformation equation, that would also be available. So click on submit, and your solution is being generated, and here you can see that your solution has been, it is generated here. So using Mohr circle method, because we chose Mohr circle. Okay, so this is the Mohr circle radius, principal stresses, principal angles, I mean planes at which these principal stresses occur, then maximum shear stress, it is given here. Okay, stresses at oblique plane, so this is your oblique plane, and this is your Mohr circle. So you can see that you get your sigma theta 1 and tau theta 1. I mean, these are the stresses at that particular angle theta, which is 30°, and 30° from this sigma x tau xy. So this is 2 theta, that is equal to 60°. Okay, so this is a Mohr circle. So let us try for some different. Let us suppose our sigma x is 30, sigma y is suppose minus 10, and to xy let us take it 10 again, and theta let us take it 45 maybe, and let us choose both methods. So submit, So using Mohr circle method, this is your first method. Now you can see that your theta, this plane is at a 90 degree from here, that is 2 theta, because theta was 45. Alright, so theta we have taken this time was 45. So this is a Mohr circle method, and this is now you're using stress transformation equations. So it gives you stress transformation equations here and all the solutions using the equations. Okay, so this is your first step. So you can draw Mohr circle for any stresses here, any kp, mp, and you can see that these units, they also get displayed here. So in mpa, everything is annotated, okay, in even in the diagram, not just answer, everywhere it is annotated like this. Each step is explained. Okay, so this is programmed in such a way that your solution would be complete. Okay, let us check now vertical curve. Okay, so this is my second app here, and vertical curve. Okay, so let us suppose as you know, vertical parabolic curves basically. So let us suppose your grade 1 is positive 2, and second grade is minus suppose 1.5, and suppose length of the curve, let us choose is 1000. So what is given? So one of the station would be given to you, okay, either PVC, PVI. Okay, so let us suppose PVI is given, then you just simply fill this box PVI. Let us suppose station PVI is 1500. Okay, and elevation of the PVI, let us suppose is 200, and ordinate spacing, I mean offsets, how full station spacing or whatever is asked from your question. They will ask that give the elevations of the station at each every 30-meter interval. So let us suppose your interval here is 100 meter. Okay, so then you just simply submit here, and now you will get your solution. So this is your station PVC, x naught is station PVI minus L by 2. Okay, so station PVI was 1500 and L was 1000. So 1500 minus 500, that is 1000. So every calculation it is done here, even equations are given to you, and high point is also calculated, and station. And for full stations, you can see this is the table which gives full stations stationings, and this is the distance from PVC. This is G1x. I know you will know all this if you have the knowledge, or you can study everything here. I mean, each step is given, so you simply, and this is your diagram of the curve. So this G1 was positive 2% and G2 was negative 1.5%. so this second tangent, it is downward, and this is your curve, and this is the high point of the curve. This is the PVC station, this is the EVC station, that is the end station, and elevation is also annotated here, here, and PVI elevation was 200. So this is your curve diagram. So this is a complete solution. Now let us check the shear force and bending moment app. Okay, so let us suppose you want to, so okay, this is the input box. Let us suppose your beam length is 10 meter. Length unit, let us suppose these are the same, meter kilonewton is the load unit, and let us suppose number of supports. Let us take a simply supported beam as of now. So let us suppose two supports are there, one at the left hand, one at the right hand, and let us take number of load, let us take one UDL, and okay, or you can take two loads also. I mean, let us take one UDL and one point load. Okay, so let number of loads is 2. Okay, then submit this detail, then another form will get generated, and you have to input the all the details of the loads and the supports. Okay, so let us suppose your load number 1, that is concentrated load, it is at, let us say it is suppose 100 kilonewton, and let it is at the node name, let us say E. Okay, and it is at the distance 5 meter from the left hand, so origin is the left hand of the beam. If UDL, so this is a concentrated load, so we need not fill these boxes, let us keep them as it is to their default value, they doesn't matter. Okay, this is the now second our second load, just ignore this one, I will simply delete this part once I update this app. So second load, let us suppose this is our UDL and its value is, let us say, 10 kilonewton per meter, and it starts from node name A, that is distance x is equal to 0, and its end point, let us suppose it as 10 meter, and load node name is B, and load value, I mean second, you don't need to fill this if it is UDL, but you can fill the same value. I mean the second value is for UVL, that is uniformly varying load. Okay, so if UVL, then you need to fill this, but even if you fill this to the same value, the result wouldn't change. Okay, and let us input the support details now. So node name A, let us suppose our beam is AB, and first node, that is left node, it is pin support. Okay, so you have four options here: fixed pin, roller, or internal hinge. I can add more if you like. I mean, yeah, but that will simply, that needs some upgradation. If you need another like zero shear or maybe some other types of supports, there are not many supports, but yeah, we can add if there are any. Okay, so let us take the second support is at node B, and let us suppose this is a roller support. Okay, and the distance from the left is 10 meter. Okay, so we have input, we have put all the details, then simply click submit. Now it will take some time, I mean a few seconds, because this is a bigger program. Okay, so shear force bending moment, first it will calculate all the equations, and then it will draw your shear force and bending diagram. So let it take some time. Okay, so it is done. All right, so this is your reaction calculations. So there will be two reactions. Okay, AY and BY. Alright, so AY and BY, it has calculated here 100. So if you remember, our UDL was 10, okay, and our point load was 100. So 100 plus 10 into 10 is 200, and due to symmetry, each reaction would be 200 divided by 2, that is 100 kilonewton. So this is your shear force and moment equations here. For 0 to 5 this equations, for 5 to 10 this equations. Each equation is, I mean, see, you can see here, for 0 to 5 this is the equation, 100 minus 10 into x kilonewton, this is the shear Vx, and moment is mx is equal to minus 5x square plus 100x, and it also gives you value of the these. At x is equal to 0, Va will be 100 kilonewton, that is reaction A, and at E, that is middle point. Okay, so reaction shear force is 50. So also, I mean, it equations plus values, and also it calculates your maximum values. Okay, so Vmax is 100 kilonewton at x is equal to 0 to 0 meter, I mean at 0 this is 100 kilonewton, and similarly maximum moment, this is your maximum, it would be rounded to 375. So this is a computer calculation, so it takes a float value here, and this is your shear force and bending moment diagram. Okay, so this is, you can see this is a parabolic shape, and this gradient, it suddenly changes because here there is a big point concentrated load, and each point is annotated, you can see. So this is a very beautiful diagram actually, and you can see. So this was our third app, and this is a free article. I have linked my website which is live as of today. If you know, I have a website which is civil engineering, this civilengineeringsoftstudies.com. So this website will get opened when you click on this free articles. Obviously I can create a section for articles in this website itself, but that is still a work to do, but currently this is my website, and you can check that there are various articles here, and they are free of cost. Okay, so that is all for now. I mean, this is the and And also I've created subscription option for users. If they want to subscribe, they will get more benefits. Obviously, and this whole website, I mean, this project has taken a lot of time and work from my side, so it would be dishonest for myself to not get any rewards for this work. Okay, I mean, I would be mean to myself. Okay, so just wait for this to get live and you can use it just as I am using it now. Okay, so that's all. Thank you. Take care. Bye bye.